Okay, so I had a few more requests for a couple other problems on the test corrections to be explained. So I'm going to go over number 8 and 10 real quick. So 8, let f be a function that is continuous on the closed interval -2 to 3, such that f prime at 0 does not exist, f prime at 2 is 0, and f double prime is less than 0 for all x except at x equals 0. So let's just go through these conditions one at a time. So first, we need the function to be continuous on our interval. So we can get rid of any options that have a discontinuity. So that eliminates D. Second, we want f prime at 0 to not exist. So for a derivative to not exist, remember graphically, that means we're going to have like a corner or a cusp or a discontinuity, but we've already eliminated the fact that it could be a discontinuity. So at 0, we need this graph to have a corner or a cusp. A, B, and E all have that cusp. C does not. So we can get rid of C. Next, we want f prime at 2 to be 0. So that means we should have either a maximum or a minimum occurring at 2, right? I guess it doesn't necessarily have to be a maximum or minimum, but we do need a slope of 0 at 2. And all of those, still A, B, and E, still do that. Now, f double prime of x is less than 0 for all x except x equals 0. So remember, the second derivative tells us about concavity. This means we need it to be concave down everywhere except at 0. Well, A, that's concave up, so we can get rid of A. B, that's concave up, so we can get rid of B. E, notice that both of these are concave down except at 0, so our answer is E. Great, let's do number 10. All right, a rectangular area is to be enclosed by a wall on one side and fencing on the other 3 sides. If 18 meters of fencing are used, what is the maximum area that can be enclosed? So let's make this side. All right, so this is my wall, and then I'll do my fencing. And I want to maximize area. I'm going to call this x and this y. And so the thing I want to maximize is area, and area is just x times y. But we need to get that in terms of a single variable before we can do calculus and optimize. So 18 meters of fencing are used. So that's actually the perimeter, right? So thinking about the perimeter, we're going to have 2 x's plus 1 y, and that's going to give us the amount of fencing we can use. So now we can isolate, in this case, probably easiest to isolate y equals 18 minus 2x. And I can take that, and I'll just substitute it into my area function to get everything in terms of x. So now I have area equals x times 18 minus 2x. And that's 18x minus 2x squared. And now I want to optimize. So we're going to take the derivative. A prime is 18 minus 4x. I'm going to set it equal to 0. I'm going to solve. So that's going to give me 18 equals 4x, or x equals 18 over 4, which is 9 over 2, or 4.5, right? And now we just want to verify that this actually does maximize our area. So remember the way to verify? I'm going to use the first derivative test. So a prime, I'm going to put my 4.5. I know that a prime is 0 there. I'm just going to test a number on either side. So over here I could test, say, 0, and when I plug in 0 to a prime, I would get 0, 18 minus 0, so that's positive. Over here I could choose 5. That'd be 18 minus 20, so that's negative. So I have my original functions going from increasing to 0 slope to decreasing. Thus, it does attain a maximum at 4.5 when x is 4.5. But the question asks, what is the maximum area? So now I actually want to plug in 4.5 to get my maximum area. So a of 4.5, and that's just going to be 4.5 times 18 minus 2 times 4.5 is 9. That's 4.5 times 9. Can't do that off the top of my head, but I'm not going to pull up the full-on calculator. We're going to pull up my phone calculator. So 4.5 times 9 is 40.5. Which is going to match E, 81/2. All right, folks, hope that helps.